There's another great device to show charging of objects via conduction and induction, and that's called an electroscope. An electroscope will measure electric charge, both the sign and the magnitude. Not terribly accurate on the magnitude, but it can at least give you orders of magnitude, and more carefully you do the experiment, you can get closer to the right magnitude. We have, let's take this example here. This shape here is a glass beaker. We have a metal rod that is supported by a cork. Let's just put a cork up here. Some kind of insulating material, so the rod is insulated from the glass, which is also an insulator, but we want to be doubly sure. And this metal rod comes down here, and I have two little hooks. On each hook is a very thin, very small mass gold leaf. Now we know that gold conducts electricity. This conductor is made out of steel or something, or aluminum. And this whole package, once again, is insulated from the glass container. If there is no charge on this metal object, and you can see how for every negative we have a positive, then the leaves will hang down. Why? Because of gravity. Gravity is pulling them down. There's no other force. We can put a charge on this either by conduction or induction, and that's what we're going to go over next. But first, let's show you how long these electroscopes have been around. Here's a book, Opfindelzemmes Bog, from 1878. I apologize for the mispronunciation. And you can see here, here's our little conductor here, goes through here. There's an insulator, and here are two gold leaves that are far apart. Here's a charging rod, and you can tell this is older because check out the cuffs and the cufflinks here. So this is from 1878. A neutral electroscope will become negatively charged when touched by a negatively charged object, just like the last chapter where we had spheres and charging rods. So we have a rod up here. We're going to say it's a negative 4Q. 1, 2, 3, 4, 5, 6, 7, 8 negatives. 1, 2, 3, 4 positives, so it's a negative 4Q. What's going to happen is this guy is going to be brought over here. It will touch this conducting surface. The excess charge will see more room to spread out. It will flow down. It will equally distribute between the gold leaves. So once each of these gold leaves has a negative charge on it, they will repel, since like charges repel. Once the rod touches this conductor up here, excess negative charge will flow through the rod into the gold leaves. An equal amount will go to each gold leaf. They both have a net negative charge, and they will repel, so they'll spread out just like this. We then move the bar away. We've left behind a net negative charge on the electroscope, and since that charge flowed from the rod to the electroscope, this now has less negative charge. But when you add up all the charge between the electroscope and the rod, you'll get the same amount of charge that you started with. We could also have done this with a positively charged rod. In that case, positive charge would flow down here. You'd have a positive on each side, they'd repel. Now you might question, what do you mean flow of positive charge? I thought you said that the protons aren't moving. Well, they're not. But when we work with electricity, if we say we have a negative charge going this way, and that's what's really happening, right? The electrons are moving. That's the same as if positive charge were to go that way. So we're really not talking about the physical movement of neutrons, or protons or electrons. We're just talking about which way the charge is going.